Okay, so let's see. The mass of the spaceship is 5.4, and this is kind of funny, right? So that's 540 kilograms, right? But we also know there's 81 kilograms of fuel, right? Now, when I first did this, I think I got it wrong. I got the wrong answer. I did not get this number here. And that's because I assumed that 540 included the fuel, but it doesn't, okay? And of course, you might do the same thing on the test, right? So the mass of the spaceship really is 540 plus 81, right? So what is that? That is 621 kilograms or something like that, right? Okay, so that step one, right? So it's sort of misleading. I feel like they intentionally ask a sort of misleading question. So then they say deduce that the initial acceleration is this. So we got to figure out the thrust of the engine, right? So this is maybe step 0 is figure out that the question's worded trickily, right? And then step 1. By the way, in the mark scheme, if you said that the mass was 540 and you arrived at a different answer, they would accept that, which is interesting. So, okay, so that's supposed to be a 1, by the way. Okay, kind of looks like a person with long hair. Anyway, so step 1 is find the thrust of the engine. So force times time is mass times change in velocity, right? And we know the change in velocity is, from the previous page, 3 times 10 to the 4th meters per second. This is, of course, the exhaust velocity of the xenon ions, right? We know that this mass is 2.2 times 10 to the minus 25th kilograms. And if they say that it is that, even if it's like 2.17, use their value because they're using their value and you'll get slightly off. That's kilograms, right, per ion, but there's 7.7 times 10 to the, 18th, right? Okay, so this is by the way from part C. Okay, so from part C, you know that it's every ion has this mass. That's actually in part B, right? And then in part C, they tell you this. That's going to be the mass every second. We did that in part C. Right? And then, of course, this is 1. We're going to use 1 second because this is kilograms per second. And you'll get the force. So when I got my force, I got something like 0.05082 or something like that. Okay, so it's very small, and that's about right. It's about 5/100ths of a newton typically for an ion drive. Okay, so force is, figure it out. You got to figure it out. Right? And then our acceleration is just force divided by mass. And then the question is the mass 540 or is it 621? If you do 621, you'll get the answer, the first answer in the thing, right? So we're using F equals ma, right? To divide that force by the mass, right? And I believe it's 540 plus 81, right? So the initial acceleration of the spaceship is that. Yeah. What's interesting is they don't ask us for the final acceleration. We don't have to subtract gravity because it's in deep space or something like that, right? We're all set, right? So step 0, read their mind and realize that they're talking about that spaceship, that's fuel, total mass is this, right? Step 1, use what we do for rockets, right? Force times time is mass delta V to figure out the thrust. The thrust is small, it's like 0.05083, something like that. And then divide that by the total mass. And you'll get an astonishingly small acceleration, which is this, right? But of course, it's going to run for 1.5 years, so that will sufficiently ramp up the speed of the ship.